Okay, now I will show you how to get a Fourier series. Fourier series is the series that in terms of sine and cosine. So the final answer for this Fourier function will be in sine and cosine. Okay, so first we identify the period. So here given the interval of this function from negative pi to pi. So what we do is we find period. Period equal to pi minus negative pi, which is equal to 2 pi. So we let to L equal to 2 pi. So we get L equal to pi. So the value of L, this value of L we use to integrate. So in our case, L is equal to pi. Okay, given the formula of A naught is A naught equal to 1 over L. So will be 1 over pi. From negative L to L. So in our case, from negative pi to pi, fx dx. In this piecewise function, we have two values of fx. Fx equal to 0 for x between negative pi and 0. And second value of fx is pi minus x for x between 0 and pi. So we need to split this fx to two integral. From negative pi to 0, fx equal to 0. From 0 to pi, given fx equal to pi minus x. So we need to integrate separately. Okay, this value we will get 0 because 0 times dx is equal to 0. So we need to integrate this one. Integrate pi equal to pi x. Integrate x equal to x squared over 2. And then we substitute by pi and 0. So we get the final answer for A naught is equal to pi over 2. Okay, next we find AN. The formula of AN is 1 over L, negative L to L, fx cos n pi x over L dx. L replaced by pi. Integrate from negative L, so negative pi to pi, fx cos nx dx. Same as A naught, we need to split this fx to two functions. The first one is 0 and the second function is pi minus x. 0 from negative pi to 0, pi minus x from 0 to pi. So integrate this one will be 0. To integrate the second term, we need to use integration by part. Let pi minus x as u, cos nx equal to v. So by using integration by part, uv minus integrate v du. Okay, we can use this tabular integration by part to make it easy. So we differentiate this u, up to 0 and then integrate cos nx, follow the number of this differentiation. Okay, we need to differentiate this one up to 0, 3. To get 0, we need to differentiate 3 times. Differentiate pi minus x, differentiate pi equal to 0. Differentiate negative x equal to negative 1. Differentiate negative 1 equal to 0. Okay, now we integrate this cos nx. Integrate cos nx equal to sin nx over n. Remember, integration cos equal to positive. Integrate sin equal to negative. Integrate sin nx equal to cos nx. Divide by n. So here we have n and then divide by n equal to n squared. Integrate sin equal to negative. and then multiply diagonal. Pi minus x times sin nx over n plus integrate plus negative 1 times negative cos nx over n squared. This value, this sign will alternate from positive to negative. So we get integration of pi minus x cos nx dx. Using this answer, we get pi minus x times this one plus negative 1 times negative equal to negative cos nx over n square, and then substitute by 0 and pi. Okay, now we substitute pi into x, so we get pi minus pi equal to 0 here, cos pi in here over n squared, and then substitute by 0, pi minus 0 over n sin 0 equal to 0, substitute 0, cos 0 over n squared, cos 0 equal to 1, so we get 1 over n squared. Okay, now we rewrite negative, positive, so we get 1 over n squared minus cos n pi over n squared. Factorize n squared, take out, we get 1 over n squared pi minus cos n pi. This cos n pi we can replace by negative 1 to the power n. How we get this term? Okay, we derive from 1 to 4. Okay, let's say cos 1 pi, we get cos pi equal to negative 1. When we substitute n equal to 2, cos 2 pi we get equal to 1, cos 3 pi equal to negative 1, cos 4 pi equal to 1. So this value will alternate from negative 1 to 1, up to 1, negative 1, and then back to positive 1. Okay, or we can write this one, negative 1 to the power 1 equal to negative 1, negative 1 power 2 equal to positive, negative 1 power 3 equal to negative, negative 1 power 4 equal to positive 1. So cos n pi same as negative 1 to the power n, whereas sin n pi is equal to 0. Okay, so we can replace cos n pi in term of negative 1 to the power n. Okay, now we proceed to find Bn. Formula of Bn, 1 over L, negative L to L, fx sin n pi x over L dx. Replace L by pi, so from negative pi to pi, fx sin n x, n pi x over pi, cancel pi, so we get nx dx. Okay, so, and then split to 2, fx 0, and fx pi to x 0, in interval negative pi to 0, pi minus x in interval 0 to pi, this one 0, then pi minus x sin n pi. When we integrate, we need to use integration by part, or we put in tabular integration. Okay, let u equal to u minus x, v equal to sin nx. Okay, by using tabular integration by part, we differentiate pi minus x, differentiate pi minus x, differentiate pi equal to 0, differentiate negative x equal to negative 1, differentiate negative 1 equal to 0, and then we need to integrate this one. Integrate sin nx, integrate sin equal to negative cos nx over n, we take here n, then integrate this one again, integrate cos nx equal to sin nx over n, n times n equal to n squared. Integrate cos equal to positive, but we have negative from this integration of sin, so follow the value of negative, and then put positive, negative here alternately. Okay, multiply diagonal, pi minus x times positive times negative cos nx over n plus negative 1 times negative sin nx over n squared equal to negative sin nx over n squared. So we put the answer in this form. Pi minus x times positive negative cos nx, we get this negative, plus negative 1 times negative, we get negative sin nx over n squared. Okay, next substitute pi and 0 into x. So first substitute pi minus pi equal to 0, sin n pi over n squared, substitute 0, pi minus 0 over n, we get pi over n, substitute 0, sin 0 over n squared equal to 0. Okay, sin n pi equal to 0. Sin n pi always equal to 0 because sin pi equal to 0, sin 2 pi equal to 0, sin 3 pi equal to 0, all 0. So we can replace sin n pi equal to 0. So our answer only pi over n. Negative, negative, positive, times by 1 over pi, we get pi over n. Simplify, so final 1 over n. After we get a0, a1, and bn, so we can put in Fourier series. This is Fourier series. So the periodic function, fx is periodic function, can be rewrite in Fourier series. This is the Fourier series in terms of cos and sine. So this is the value of a0, this is the value of an, okay, an, and then this is the value of bn. And then remember to write this cos nn and sin nn nx, cos nx and cosine nx.